Okay, get this. Imagine, just imagine, a world where our electric grids hum with power, fueled by sunshine and wind, thanks to batteries. Um, but not just any batteries. Batteries made from something we usually just toss away. Sounds a little bit like science fiction, right?
It
Well,
does.
stick with me, because researchers at Northwestern University might just be turning that sci-fi dream into reality. They've made a discovery about, well, you could call it a common waste product,
Mhm.
triphenyl phosphine oxide, or TPPO for short, and how it could revolutionize energy storage. I mean, who would have thought?
What's really intriguing about this is that it isn't just about making batteries a bit better. We're potentially talking about a whole new approach to energy storage with something called redox flow batteries.
Okay, I have to admit, when you say redox flow batteries, I'm picturing glowing tanks of liquid from, like, a movie set,
Yeah.
But I'm trusting there's more to it than that. What exactly are these redox flow batteries, and how do they differ from, like, the everyday batteries we're all used to?
You can think of it this way. Those lithium-ion batteries in your phone or laptop, those are like solid bricks of energy storage, right?
Right.
Redox flow batteries, on the other hand, those are more like liquid energy reservoirs. So you have these two tanks of electrolytes, think specialized liquids, basically, one positively charged and one negatively charged. The energy is stored in the chemical differences between those liquids.
So instead of those bulky battery packs, we could have tanks of liquid doing the work. That's actually a really cool concept. I like it.
Right.
But where does this TPPO waste product come in? How does it fit into all of this?
So for a long time, people considered TPPO pretty much useless.
Really?
Oh, yeah. It's just a byproduct of a lot of different chemical processes. People just discarded it.
Wow.
But the researchers at Northwestern, they discovered that TPPO has like a hidden talent.
Hmm.
You could say it can act as what we call a redox active component in these batteries.
Wait, so they're taking something we treat as trash and turning it into, like, a key ingredient for batteries. That's wild. What makes TPPO so special for this? Don't these batteries need, like, super precise and high-tech materials?
You'd think so, right? But that's part of what makes this discovery so remarkable. The thing about TPPO is it's exceptionally stable, even in that, harsh environment inside a battery. And it can handle hundreds of charge and discharge cycles without breaking down, which is a big hurdle that other materials struggle to overcome.
So you're telling me TPPO is like the marathon runner of battery materials, just going the distance without getting tired. That's pretty impressive. But I have to ask, help me understand the so what here. Why should the average person, why should they care about TPPO and batteries? What does this actually mean for, everyday life?
So this is where it gets really exciting, right? Remember those big tanks of electrolytes we were talking about? That means redox flow batteries can be scaled up much more easily than typical batteries. Imagine having massive energy storage, like for entire neighborhoods or even cities.
Okay, now you've got my attention. So we're talking about potentially using this recycled waste product to make renewable energy more reliable and on a huge scale. This all sounds almost too good to be true.
It's definitely a game changer. And there's more. TPPO isn't just good at holding a charge, it also outperforms other materials in a key area, which is energy density.
Okay, now you're using the technical terms again. Just remind me, what exactly does energy density mean, and why is it so important?
Think of it like this. A higher energy density means you can pack more energy into the same amount of space.
Okay.
And this is crucial for making things like electric vehicles practical. You want a battery that's powerful but also compact.
Got it.
Yeah.
So TPPO is basically giving us more bang for our buck, energy-wise.
Mhm.
But wasn't lithium supposed to be the wonder material for batteries? How does TPPO compare to lithium?
Yeah, lithium has its place, but it comes with some, I guess you could say, baggage. It's expensive to mine, and those mining operations, they can be environmentally damaging. PPPO, on the other hand, is a byproduct that we're currently just throwing away. It's potentially cheaper, more sustainable, and as this research shows, it can outperform lithium in some key areas.
I'm kind of blown away by this. So we have a potential solution to both our energy needs, A&D, our waste problem,
Sure.
all thanks to this TPPO discovery. What are the chances? What else did they uncover in this research?
Well, one of the most striking things they found is that TPPO is actually the first phosphine oxide to ever be used as a redox active component in batteries. It's not just about the specific material. It's opening up a whole new avenue of research in sustainable energy storage.
So this isn't just a single discovery. It's potentially the key that unlocks a whole new field of possibilities.
Hmm.
I have to ask, how did they even figure out that TPPO could be used this way? It wasn't just a lucky guess, was it?
No, of course not. This was the result of years of dedicated research and a lot of trial and error. The team at Northwestern, they had to look at the problem from a fresh perspective and challenge existing assumptions about what makes a good battery material.
That's what I love about science. It's all about pushing boundaries and looking for answers in unexpected places. But I'm also thinking about the practical side of things here. How do we go from a lab experiment to actually using TPPO in real-world batteries? What are the next steps?
That's a great question. And there are a few key challenges to overcome. First, we need to scale up production. Right now, the synthesis of TPPO for battery use is done on a relatively small scale.
So we need to figure out how to make a lot of TPPO and do it efficiently and cost-effectively. That sounds like a pretty big task.
It definitely is. And even once we figure out the manufacturing side, we need to think about design. Redox flow batteries, they're a different beast than your typical lithium-ion battery.
So it's not just a matter of swapping out the lithium for TPPO. We need to rethink how the whole battery is built.
Exactly. We need to optimize the design of the entire battery system to take full advantage of TPPO's unique properties.
This is starting to sound like a pretty complex puzzle. But with all the potential benefits, it seems well worth solving. But I'm curious, are there any downsides to using TPPO in batteries? Nothing's perfect, right?
You're right, every technology has its trade-offs. One potential drawback of redox flow batteries is that they can be a bit bulky, especially compared to those compact lithium-ion batteries. Remember those tanks of electrolytes?
Right. So while they might be great for like grid scale storage, we're probably not going to see TPPO-powered smartphones anytime soon.
Probably not. But remember, this research is still in its early stages. There's a lot of potential for improvement and innovation. Who knows, maybe someday we'll see compact redox flow batteries using TPPO.
I love that optimism. It's exciting to think about all the possibilities. But before we get too carried away with dreams of the future, I want to come back to something you mentioned earlier. You said that TPPO isn't just good for batteries. It could have other applications as well. Can you tell me more about that?
Absolutely. Researchers are already exploring the use of TPPO in other fields, like catalysis and materials science. Its unique chemical properties make it a promising candidate for a wide range of applications.
So this discovery could have ripple effects far beyond just the realm of energy storage. That's incredible. Can you give me some specific examples of how TPPO might be used in these other fields?
One area where TPPO is showing a lot of promise is in catalysis. It can act as what we call a catalyst, which means it can speed up chemical reactions without being consumed in the process.
Interesting. So it's like a chemical matchmaker helping reactions happen faster and more efficiently? What kind of reactions are we talking about here?
There's a wide range of possibilities, from producing pharmaceuticals to developing new materials.
Wow, so this waste product could actually play a role in creating life-saving drugs, or even the materials of the future. That's pretty amazing.
It really is, and that's just one example. Researchers are also exploring the use of TPPO in material science, where it could be used to create new polymers and other advanced materials.
Okay, I'm officially blown away. This TPPO discovery is like opening a Pandora's box of possibilities. It's truly inspiring to see how scientific curiosity and a little bit of ingenuity can lead to such groundbreaking discoveries.
I completely agree. And who knows what other breakthroughs are just waiting to be uncovered.
Well, we're going to keep digging for those answers.
Mhm.
Before we move on, I want to take a closer look at how this TPPO battery actually works, what makes it tick, what's going on at the molecular level.
That's a great question. To really grasp the significance of TPPO, we need to delve a little deeper into the chemistry behind these redox flow batteries. So in a traditional lithium-ion battery, you have those lithium ions, and they're shuffling back and forth between the anode and cathode, right? That's how they store and release energy.
Okay.
But with a redox flow battery, things get a bit more, I guess you could say, dynamic.
Okay, yeah, I'm picturing those electrolytes we talked about flowing, like almost like rivers of energy. What happens next?
Exactly. The energy is stored in the different oxidation states of those electrolytes, and they're pumped through the battery. As they pass over the electrodes, that's when the chemical reactions happen, and, well, that's where the magic happens. That's where the energy is either stored or released.
So we've got these electrolytes constantly on the move, reacting at the electrodes. It's almost like a mini power plant inside the battery itself.
Yeah, that's a great way to visualize it. And what's really neat about this design is that you can easily scale up the capacity. Just use bigger tanks, for your electrolytes.
So theoretically, we could have massive batteries to power entire cities, all thanks to tanks of liquid and this TPPO molecule.
That's the idea. And that's where the durability of TPPO really shines, right? You see, these electrolytes, they can be pretty corrosive. Other materials might degrade over time, but TPPO, it stands strong. It can handle hundreds of those charge and discharge cycles without breaking down.
So TPPO is tough, it's efficient, and it's scalable. Are there any hurdles to overcome, you think, before we start seeing this technology, everywhere?
Well, there are always challenges when you're dealing with new technology. One limitation with redox flow batteries, it's their energy density by volume compared to lithium-ion batteries.
So maybe not TPPO-powered smartphones just yet, but like you said, this research is still in the early stages, so there's definitely room for improvement. What are scientists focusing on now? What are they trying to figure out?
Well, the team at Northwestern and others around the world, they're working on boosting that energy density even further. Tinkering with the electrolyte recipes, experimenting with different materials, exploring new designs for the batteries themselves.
It's exciting to think what the future holds for this technology, but let's shift gears for a moment and talk about cost. You mentioned that TPPO is cheaper than lithium, but how does that translate to like the actual price of these batteries?
Well, the cost of the raw materials, that's a big piece of the puzzle, but it's not the whole picture. Manufacturing processes, economies of scale, research and development costs, all of that plays a role.
So even though TPPO is relatively cheap to source, there are other factors that could impact, the final price tag.
Precisely. But the fact that we're starting with a waste product, that's a huge advantage. It cuts down on mining and processing costs, which are significant expenses for traditional battery materials.
So we're not just talking about environmental benefits, but also potential cost savings. That's a win-win. What would you say is like the most important takeaway from all of this research on TPPO and redox flow batteries?
I think biggest takeaway for me, at least, is the power of creative thinking and challenging assumptions. For years, TPPO, it was viewed as a waste product, just a nuisance. But by looking at it with fresh eyes, these researchers uncovered its hidden potential.
It's a reminder that innovation can come from the most unexpected places, and that sometimes the solutions to our biggest problems they're right under our noses.
I have to admit I'm feeling a bit more optimistic about the future of sustainable energy after learning about this discovery. I share your optimism. This research it's a testament to human ingenuity and our capacity to find solutions even in the face of, these daunting challenges.
Speaking of challenges, we've talked about, scaling up production and optimizing battery design. What are some of the other obstacles that need to be addressed before we start seeing, TPPO batteries powering our homes and cities?
One of the biggest hurdles is going to be industry buy-in. We need companies to invest in and adopt this new technology. It's not enough for it to work in a lab setting, right? It needs to be commercially viable.
So it's not just about the science, it's also about convincing businesses that TPPO is a worthwhile investment.
Exactly. We need to demonstrate the long-term, economic and environmental benefits of these TPPO-based batteries.
Right. It's all about showing companies that this is not just like a feel-good green initiative,
Yeah,
but a smart business decision as well.
absolutely. And that involves, proving that TPPO batteries can perform reliably, meet industry standards, and really compete with existing battery technologies.
It sounds like a lot of pieces need to fall into place. But with so much potential on the line, it seems like a challenge worth taking on.
I agree. And remember, this is a global effort. Researchers, engineers, businesses around the world, they're all working together to bring these TPPO-based batteries to the market.
It's inspiring to see that kind of like global collaboration in action. It really gives me hope for the future.
It's a reminder that we're not alone in this endeavor, right? We're all part of a collective effort to create a more sustainable and prosperous future.
This has been such a fascinating and thought-provoking deep dive. I feel like I've learned so much about TPPO and redox flow batteries and the potential they hold for the future of energy storage.
It's been my pleasure to share these insights with you.
We've covered a lot of ground, but there's one more aspect of this TPPO story I want to touch on. We've talked about TPPO being a waste product and its potential to reduce our reliance on lithium mining, but what are the bigger picture environmental benefits of this discovery?
That's an excellent question, and it's an important one to consider. The environmental benefits of TPPO go far beyond just reducing waste.
So we've talked about TPPO being a more sustainable alternative to lithium, but how does this all tie into the bigger picture of, creating a greener energy landscape.
Well, let's think about those renewable energy sources like, solar and wind power.
Yeah,
They're fantastic for generating clean energy, but they're intermittent, right? Meaning they're not always available when we need them.
right, right. The sun isn't always shining, the wind isn't always blowing. That's where energy storage comes in, right? We need a way to store that clean energy for when we actually need it.
Exactly. And that's where TPPO and redoxable batteries could really, really make a difference. Imagine having these large-scale energy storage systems that can capture that excess solar or wind power and then release it when the demand is high. That's the key to making renewable energy a truly reliable and viable alternative to fossil fuels.
It's like having a giant energy savings account for the planet. Right.
Exactly.
We can deposit clean energy when we have a surplus and then withdraw it when we need it. But it's not just about storing renewable energy, is it?
Yeah.
TPPO could also help reduce our reliance on fossil fuels in other ways too, right?
That's right. Think about the transportation sector, for example.
Okay, yeah.
Electric vehicles are becoming increasingly popular, but the batteries they use are still, heavily reliant on lithium, which, as we discussed, has its own set of environmental challenges.
So by replacing lithium with TPPO like EV batteries, we could create a cleaner and more sustainable transportation system. That's a pretty big deal.
It is, and it's not just about cars, right? TPPO could also be used in batteries for electric buses, trucks, maybe even airplanes someday. I mean, the potential it's vast.
It's incredible to think about all the ways this one discovery could transform our world for the better.
Yeah.
But I also wanted to touch on something we discussed earlier, TPPO's potential applications beyond energy storage. You mentioned catalysis and material science. Can you expand on that a bit more?
Absolutely. In the realm of catalysis, TPPO can be used to create more efficient and, more importantly, more environmentally friendly chemical processes.
Okay.
This could revolutionize everything, from how we manufacture pharmaceuticals to how we produce those everyday materials we all use.
So we could be talking about creating medicines with less waste, using fewer harmful chemicals, and ultimately, reducing our environmental footprint.
Exactly. And in material science, TPPO, it's showing promise as a building block for new polymers and composites. These materials could have a wide range of applications, from creating lighter and stronger building materials to developing, more durable and sustainable textiles.
It's like TPPO is this incredible multi-tool that can be used to tackle so many different challenges. I have to say, I'm finding it hard to contain my excitement about all of this. What are you most excited about when it comes to the future of TPPO research?
What excites me the most is, honestly, the unknown. We've only just scratched the surface of TPPO's potential. And as researchers continue to explore its properties and applications, who knows what amazing discoveries they'll uncover. Maybe we'll find even more ways to use TPPO to create a more sustainable and equitable world.
It's a reminder that the journey of scientific discovery, it's never truly over.
Yeah, that's right.
There's always something new to learn, something new to explore. And that's what makes this whole field so fascinating. So what can our listeners take away from all of this? What's the big message you want to leave them with?
I think the most important takeaway is that there's hope. We face some serious challenges when it comes to energy, climate change, and sustainability in general. But discoveries like this one with TPPO, they show that we have the ingenuity and the creativity to find solutions. We just need to keep pushing the boundaries, keep challenging assumptions, and, most importantly, keep working together to create a better future for all.
Beautifully said. And to our listeners, I hope this deep dive has left you feeling inspired and energized, just like it has for us. It's a reminder that even amidst all the challenges that we face, there are these brilliant minds out there working tirelessly to create a brighter tomorrow.
It's been a pleasure sharing this journey of discovery with you.
And to our listeners, thank you for joining us on this deep dive into the world of TPPO and its potential to really reshape our future.
We'll be back next time with another fascinating topic and a fresh perspective on the world around us. Until then, keep exploring, keep asking questions, and never stop believing in the power of human ingenuity.